Hello, gentlemen. Welcome to week 5. We're going to continue our study of trig functions. We're going to look at some fundamental identities in this video and use them to show some, to prove some equations and show that some equality. So let's get started. Here's the general outline of some of the fundamental trig identities that we've worked with. We know the reciprocal identities. We learned those a long time ago. The quotient identities and the Pythagorean identities. These are very important, ones that people don't typically think of when they think about the Pythagorean identities of the tangent and the secant ones, these ones right here. We'll use that today in a couple of the examples. Again, these cofunction identities, right here, we'll use these. Okay, make sure you understand them, and the even odd, and understanding that secant and cosine are both even functions. These two are even right here, and the others are odd. So these are even right there. And remember, a function is even if f of negative x is equal to f of x. That means we're even. And f of negative x equals negative f of x. Oops. And we're odd. Okay? So you should remember those two things, and we're going to use the fact here in the next couple days to show some different expressions. So let's do some of these simplifying the expressions. So we have tan x times cosecant x. When in doubt, if nothing simplifies right off the bat, my advice is to change the sines and cosines and see what happens. Tangent is sine over cosine times 1 over sine. If you look carefully here, we can cancel out the sines, and we get 1 over cosine, and we know that 1 over cosine x, using the reciprocal identity, is just secant x. Okay? 1 minus cosine squared times cosecant squared. This, you should see, we can use a Pythagorean identity. That's just sine squared. So we have sine squared times cosecant. You can't put that in the sine, so I get sine squared x times 1 over sine x, and that's simply going to be equal to sine of x. Okay. Cosine squared times secant squared minus 1. Again, we can use the Pythagorean identity right there. We should see that that's tangent squared of x. So I have cosine squared times, this is again right here, this part is tan squared. Okay, this is tan squared. So right here the cosine squareds are going to cancel out, and I'm simply left with sine squared x. We got secant squared times 1 minus sine squared. Again, we can use this. This is a Pythagorean identity. Oftentimes we're going to see it 1 minus sine squared or 1 minus cosine squared, but the Pythagorean identity is cosine squared x plus sine squared x is equal to 1. And so this part right here can be replaced with cosine squared. So I have secant squared, which is 1 over cosine squared. So I have 1 over cosine squared times cosine squared, and that will simply equal 1. Here, we're going to use the cofunction identity. Okay, we have cotangent pi over 2 minus x. This term right here can be simplified to tangent of x. So again, tan is sine over cosine times cosine is going to simplify to sine x. Okay. We got cosecant x, tan x plus secant x. Doesn't look like there's much that I can do here. Again, let's plug back our sines and cosines. Secant is 1 over sine. Tangent is sine over cosine plus secant x. Look what happens to the sine x. The sine x's here are going to cancel. I'm going to get 1 over cosine x. This right here, we know from our reciprocal identities, is simply equal to secant x. So I get secant x plus secant x is equal to 2 secant x. This part right here is secant x as well. Okay? Sine squared x times cosecant squared x minus sine squared x. Let's factor out a sine squared x and see what that does for us. This term right here is another Pythagorean identity, and the Pythagorean identity that we would use here is going to be 1 plus cotangent squared of x is equal to cosecant square root of x. They're not always going to be in this general form, but this is the equation. In this particular example, this 1 was brought over, so this term right here is going to be equal to cotangent squared of x. Okay, so this term right there is cotangent squared of x from above. Okay. Once I have this here, let's put in the cotangent, the sines and cosines, so that I have sine squared over sine squared. That's going to cancel. These two are going to go away, and I'm going to left with cosine squared of x. Cosine squared x minus 4 over cosine x minus 2. Here we can do some factoring. Okay. We can factor the top because we have the difference of two squares. So again, just because we're doing trig doesn't mean we're gonna, not use some of our basic rules that we already know. So let's factor the top. If we do that, cosine x plus 2, cosine x minus 2, these two terms are going to cancel off, and we're just going to get cosine x plus 2. Do one more. Let's do the same type of idea here. Again, I have secant to the 4th x minus tan to the 4th x. I can factor this out right here to this because we have difference of two squares. I could do that again here. Let's see if we can reduce anything down here. Let's look at one of our Pythagorean identities, which was 1. Whoops. Let me get that back. Let me show you that one. I have 1 plus tangent squared of x is equal to secant squared of x. Well, I have secant squared x minus tan x, so if I bring the tan x over there, we get 1 equals secant squared of x minus tan squared of x. So I can simplify this statement here down to 1 right there, like that. And I get secant squared x plus tan squared x. I could, if I wanted to, have combined those because secant squared is 1 over cosine squared x, and I can have plus sine squared x over cosine squared of x. So I could have wrote it as 1 plus sine squared of x over cosine squared of x if I wanted to, but this is fine right there. Okay. Here's some practice, fellas. I want you to read these pages. It's part of the first section in chapter 5. Here's some practice problems getting used to using these trigonometric identities. We're going to do some more practice on this in the next video because this stuff is important. You need to understand the relationship between these different types of functions. Is the function identities. You need to use the Pythagorean identities because they're going to come in handy as we start to solve trigonometric equations. Okay? Have a good day, fellas. Make sure that you're emailing me if you have any questions.